Folded Cascode. The idea behind Cascode structure is to convert the input voltage to a current and apply the result to a common gate stage. However, the input device and the Cascode device need not be of the same type. For example, as depicted in figure A, the PMOS and NMOS combination performs the same function. In order to bias M1 and M2, a current source must be added as in figure B. The small signal operation is as follows. If Vin becomes more positive, mod ID1 decreases, forcing ID2 to increase and hence Vout to drop. The voltage gain and output impedance of the circuit can be obtained as calculated for the NMOS and NMOS. Here you can see the figure A. Simple folded cascode. B. Folded cascode with proper biasing. C. Folded cascode with NMOS input. Cascode of figure shown in figure is an NMOS PMOS cascode. The advantages and disadvantages of these types will be explained later. The structures of figures B and C are called folded cascode stages because the small signal current is folded up in figure or down in figure B or down in figure C. Note that the total bias current in this case must be higher than that in figure to achieve comparable performance. It is instructive to examine large signal behavior of a folded cascode stage. Suppose in figure B, Vin decreases from VDD to 0 for Vin greater than VDD minus mod VTH1 M1 is off and M2 carries all of I1 whole square, yielding Vout equal to VDD minus I1 ID for Vin less than VD minus mod VTH1 M1 turns out in saturation, giving ID2 equal to I1 minus 1 by 2 nu P C naught X W by L1 VDD minus Vin minus VTH1 whole square. As Vin drops, ID2 decreases further, falling to 0 if ID1 is equal to I1. For this to occur, 1 by 2 nu P C naught X W by L1 VDD minus Vin minus mod VTH1 whole square equal to I1. Thus V1 equal to VDD minus root over I2 Vn1 equal to VDD minus root over 2 I1 by nu P C naught X W by L1 minus mod VTH1. If Vin falls below this level, ID1 tends to be greater than I1 and M1 enters the triode region so as to allow ID1 is equal to I1. The result is plotted in figure. Now what happens to Vx if the above in the above test? As ID2 drops, Vx rises, reaching Vb minus VTH2 for ID2 is equal to 0. As M1 enters the triode region, Vx approaches VDD. If I1 is excessively large, M2 may enter deep triode region, possibly driving I1 into the triode region as well. Here you can see in this figure large signal characteristics of folded cascode. In order to achieve a high voltage gain, the load of a folded cascode can be implemented as a cascode itself. This structure is studied more extensively in chapter. Throughout this chapter, we have attempted to increase the output resistance of voltage amplifier so as to obtain a high gain. This may seem to make the speed of the circuit quite susceptible to the load capacitance. However, as explained in chapter, a high output impedance per se does not pose a serious issue if the amplifier is placed in a proper feedback loop. Thank you.